Now, if you've watched us this morning from the live from the Marsyard, you've heard about the relevance of the interaction between machines, and this is a machine competition in a certain way, and the humans operating it. And we've really seen that the human factor is the critical factor of winning or losing here on the Marsyard, but obviously also on Mars. And that is something that we're going to talk about now with my guest here from the Polish Space Agency Polsa, Przemysław Rudź. So welcome,
Hello.
Mr. Rudź,
Hello.
on the Marsyard.
Hello, everyone.
On the edge of Earth and Mars, as we were saying earlier. And I would really like to discuss with you the human factor. And not just the human factor as we see it here in the competition, but also what this competition means for inspiration and for people who are aspiring a career in the space industry. And I believe that Polsa is supporting that. Can you tell us a little bit about that?
Yeah, we are really interested in space career paths to show to everyone what they can do to get in space sector. And one of our activity is Future Space project. Future Space program. It's a part of Erasmus Plus program, and we are close to finish it. This is the last month of this project. The leader of the project is Space Research Center of Polish Academy of Science. Polsa is a member of this group. We also work together with our partners from Netherlands. This is NEMO Center, Education Center, and Noesis Education Center. And Future Space project is considered as a, in my opinion, is a first attempt to give the teachers in primary and secondary schools, give them tools to show how their pupils can make first step in the education. Sometimes very early education to think about their future. So the future in space sector. So my goal as a Polish Space Agency part of this activity was preparing several scripts for teachers, such topics like global warming, Earth observation, living on orbit, some topics from astronomy or astrophysics, how to observe the sun, how to observe constellations. I think that everyone who is interested to be a part in his future, to be a part of space sector, can use those scripts even outside the school. Use them for himself, but I think it is only the first attempt to show to authorities a very important thing, that we have to think about changing curriculums in schools, because lots of curriculums was made lots of years ago with really small changes. Now we live, close between Earth and Mars, and such informations about astronomy, astrophysics, astronautics, Earth observations, and a very important thing, maybe very funny, but in school teachers learn as geography, or biology, chemistry. We have these sciences have the equivalent in cosmic sector, biology, astrobiology, chemistry, astrochemistry, geology, astrogeology, climatology, planetary climatology. So when we will go further in the future, when, let's say, we will discover ancient civilizations on other planets, there will be place for planetary archaeology. So we need lawyers, because the world still needs cosmic law. There is a very small number of law acts for every nations. So in space sector there is a place for technicians, for engineers, for specialists in natural science, and for mathematicians and for physicians. So Future Space Project is considered as a activity for pupils, for primary and secondary schools, but especially in secondary schools, this young people thinks about what they have to do to become a part of this sector.
Okay, wow, that was a very long story.
Yeah.
You say that the project is ending.
Yeah,
Do you have any results?
2 or 3 weeks.
Can you share some results?
Yeah, the results could be studied in a dedicated website, futurespaceproject.eu.
Futurespaceproject.eu. Okay.
That's right. So there are scripts, there are programs for educational centers, and interviews with professionals from space sector to show what they do, how they get to the place they are at the moment. So you are welcome to visit.
Okay, very interesting. That material, will that remain available after the project finishes?
Yes, of course.
To teachers and to anyone who wants to use it?
Yes, of course. In Polish language, in English, and Dutch, and in Greece.
Very good. Multiple languages. That is what we like to see in communication, because it's not all English that we speak in space, even though we do right here, right now, but that is not the leading language. So thank you very much for those insights, Przemek. And with that, I would like to hand over to my friend Tadeusz here.
Thank you.
So thank you very much for being here.
Thank you.
So Tadeusz, thank you for joining us and welcome. Can you quickly introduce yourself and tell the audience what it is that you do in the ERC?
Well, my name is Tadeusz Kocman. I come from Poland, and here at the European Rover Challenge, I am the member of jury who is currently responsible for the probing and collection task.
Probing and collection. Can you tell us a little bit about what that means?
So the gist of this trial is for the teams to navigate the rover to previously selected 4 points where they should drop small probes of about 180 grams weight into, as I said, pre-selected points. And the distance between the tip of the probe and the selected point should be as small as possible to get maximum number of points. There is, of course, also many points that they can gain for using some autonomy in the gripper operation or autonomously navigating to the points where the coordinates are given. Okay,
so they place probes and they pick them up later again, or you say collection?
Well, in this case, we actually only drop them for a collection maybe by one of the future Mars missions. And the collection task is actually soil collection. So teams using their rover might use their gripper to collect a sample of the terrain, of the soil that is there on Marsyard, and place it in a specialized container that is part of the rover. Later on also, sometimes, this was very impressive from the German team Frost, doing some extra science. And there, again, you can get some points for using autonomy in placement of the soil sample in your container, and also for taking the sample as close as possible to a pre-selected coordinate point on the Marsyard.
Okay. Well, that's very interesting. And that's actually what the Perseverance rover is doing on Mars right now, isn't it?
Pretty much so, yes.
Okay, that's very interesting. How are the teams doing so far?
Well, there are ups and downs. We just recently had a very eventful run by another German team. And what happened there is that when they were heading for their 4th probe drop point, actually 2 of their wheels broke. They are plastic wheels which are surrounded by like a moving element. It's basically looks like a small tank. 2 of those plastic wheels broke, and the team had to do something like a Formula One pit stop to actually exchange them. And they managed to do it in an amazing time of about 4.5 minutes, which allowed them to go further and actually gain some more points for finally placing the probe exactly 0.7 meters from the predefined place.
Okay. Now that sounds very impressive from a competition point of view, but on Mars, if your wheel breaks, it's game over, right?
Unfortunately so, yeah.
Yeah.
And actually what we should be teaching the students from the rover teams here is that their design needs to be as sturdy as possible, as reliable as possible, both in terms of mechanics, electronics, software. So they should put a lot of time into both analyzing and then also testing. And what I've seen also with one of the other teams is that they tried to test placing the probes from their container and dropping them on the ground. But unfortunately, they were using very much lighter probes.
Okay.
And here, in the shaky movement of the rover on the Marsyard, actually their container was not able to hold the slightly heavier probes, and they fell out without the team actually noticing this. So what's also important is to have full vision of what's going in front, on the sides, and also at the back of the rover.
Sure.
Because this actually did not allow them to get any points in that trial.
Now, the teams get that information about the weight and size of the probes beforehand, don't they?
That's actually true. So just like in the space industry, it's really important to take time to familiarize yourself with all the requirements, with the required way that they should be demonstrated in a space mission. And this is also something that we try to teach through this competition here. This is probably the first time where some of those requirements are imposed on them so strictly. It's also important for them to be here on time when their trial is planned, is scheduled. And well, I need to mention that due to foreseen rain tomorrow, we had to make some shifts to the schedule. So there were some surprises to them. We apologize for that, but it's something that we just had to do.
Exactly, and again, that is in line with reality where unexpected things happen and you have to be on time and certain things last longer or...
What about the sandstorm on Mars?
Exactly, you just have to sit it out and wait it out. So no, that's definitely true. You mentioned something really important, and that is the educational element to the teams, but maybe also to the greater community. The teams can be quite large. I talked to a team, a Swiss team that has 50 people in it. Not all of them are here, but 50 people working on the rover. That's an amazing team. So the education element, you said the teams are learning from this. How does the competition help them to put in these learnings, and how are these learnings then taken through to even bigger communities, maybe back at the university?
Well, so I think, like you also touched upon the point of how to organize the work. This is quite a large project to be organized by a team of students. And project management, project structuring, tools like work breakdown structure, we also try to implement those as part of the presentation task within the ERC.
Presentation task?
Yeah,
Explain.
so, well, presentation task is for teams. They have about 20-25 minutes to present themselves, then the way they are working together, the technical solutions that they implemented within their rover, the testing that they plan to do, any software tools that they have used, and also quite importantly about the outreach. So the ERC is also heavily about the outreach. So we ask them to show them that they are engaging with the local community, that they are active on social media, promoting this competition to a wider audience.
Well, and hopefully many of the viewers here online have picked up on that promotion and are watching us now because of that promotion. And I see some teams are more visible than others, but that's an important part. And again, I keep coming back to this. This is reflecting reality, isn't it? Because these missions, often financed with public money, with taxpayers' money, the information needs to flow back to society somehow, and outreach, of course, is one of the things. So again, this is reflecting reality to do these presentations and this outreach, isn't it?
Yeah, definitely. What you mentioned is that if there was no support for the space research and no common knowledge about how much advantage we are gaining with space, like resources that are generated in space, the navigation data, the Earth observation data, meteorological data. I think the ERC is just the first step for the students to show to the students that the outreach is also an important part of the job.
Yeah.
We also see it in our business environment. It's important to also be active and tell about all the success that you've had.
Yeah, exactly. And in business, we call that marketing, and we do it because that's the way to sell our products. But in public projects and in space, we often call it outreach, because
Indeed.
we basically sell it back to society in benefits, but also in inspiration and all these things. So, yeah, I'm glad the teams are involved in that. We've got 1 more minute. As a jury member, how does these the scoring in your area, the collection and the placing of probes? How does the scoring work? How do you determine which team will win that part of the competition?
Well, so we actually have quite a detailed, predefined way how to score on certain parts of this trial. So I mentioned the distance from the point where where the probe was dropped and the marker. But there is also some points for technical excellence. So, for example, if a team really amazes us with their gripper design, or just has a brilliant idea how to implement a container onto their rover, so that it's useful for this competition, then they can also get some additional 10 points, which might bring them a little bit closer to the top places within the pack.
Okay, well, excellent. That's good to hear. Thank you for all that information and for explaining to us yet another little piece of the competition. And we'll continue to do these interviews during our live from the Marsyard intermission. So thank you very much, Tadeusz. And
thank you, Remco.
We'll hand it over to you, Piotr, if you could join us. So, Piotr, welcome to Mars and to our live stream.
Hello, it's nice to meet you.
You're part of the science team?
Yeah, I am.
But instead of talking about the science here, we may have some time to do that in a few minutes, but I found it interesting because you don't you're not a rocket science, you're not a space scientist, are you?
No, I am actually not. I am a geographer from University of Warsaw, and it is quite confusing, I find, and I was confused myself when I found out that I could study space, study Mars after geography. But it's actually pretty logical because geography is divided into 3 subdivisions. Mm-hmm. There's physical geography, socio-economic geography, and then there's something that's called remote sensing and GIS.
Of course.
And it's strongly connected to cartography. And from there, we can jump to space, basically, because cartography is something that will be crucially needed in the future of space exploration. And I feel like it's quite a niche topic because in Poland, there's basically no stuff like planetary cartography. Mm-hmm. There's planetary geology, for example, but
yes.
Yeah, planetary cartography is not really a thing. But that is also a thing that I'm interested in and that I have some experience in because I was a part of Polish Atlas this year and I made 3 maps of Mars, Venus and Moon. So yeah, that's how I got into space, basically. Okay,
very cool. So you're a geographer. For the viewers, can you really briefly explain? Because we had a geologist here this morning, Dr. Anna Losiak. She's a geologist, of course.
She was my supervisor.
I see. What is the difference between a geologist and a geographer?
A geologist is, it will be really simple, but it is more of a physical studies of rocks, of stuff that is happening, for example, on Marsyard. And geography is really, really, really broad plane of study. As I said, there are 3 major subdivisions, And geology is kind of a part of physical geography.
Okay, I see. Now, you talked about physical geography. Obviously, societal geography and cultural geography, that doesn't exist outside planet Earth. But
Not yet.
But not yet. That's exactly right. That's exactly right, because we talked about that before. But physical geography and also remote sensing and Earth or planetary observation, of course, are. So how well known is it to the geography community, if you like, in Poland or maybe in Europe, that there are careers in space for people like yourself?
I feel like basically not at all. I found it myself after 3 years of studying geography by pure chance, by checking out website of my department because they had propositions of master thesis there, and I saw like, oh, there's something related to Mars. Why not take that? And that's how it started.
Okay, but how about your curriculum? Is there nothing extraterrestrial in your curriculum at all?
My studies actually were the start of my space studies related stuff, because from the science point of view, I started writing some articles, some papers related to my master thesis, and I actually won an award at LPI this year.
Oh, very good. Congratulations.
Thank you. It was connected to latitude-dependent mantle on Mars.
Yeah, just for our viewers, LPI is the
Lunar and Planetary Institute.
Yeah.
And LPSC is a conference of that institute.
Yeah, exactly.
And my studies were connected to latitude-dependent mantle, which is a possibly water-holding layer covering a part of Mars.
Okay, but your master's thesis was about Mars specifically and not about Earth. And
Yes.
I can imagine that most of your fellow students do look at Earth, because that is the obvious thing. So
generally speaking, remote sensing is quite widely present at universities at the moment. And of course, we have many satellites across planet Earth, across which we can study our planet. And that's actually the thing that I am doing in my work, like in my day work.
But we do have, just to mention it to the viewers, but also asking you, we do have planetary observers, satellites, orbiting the Moon and Mars, for example.
Yeah, we do have, absolutely.
Yeah.
For example, we have MOLA sensor that's present on Mars and LOLA sensor that is present on Moon.
Yes.
Which I used for my base maps for my maps, because they are laser sensors, which are great for estimating height of certain points on planets.
Yeah, exactly. So really, we're calling out to all geographers to consider a career in space, because
absolutely, it's awesome.
There is a place in space for everyone, as we always say, and that includes geographers. So thank you very much, Piotr, for joining us.
Thank you.
And
it was a pleasure.
Thank you very much for your story, and we'll hand over to Kamil. So, Kamil, thank you for joining us. Tell us a little bit to the audience who you are and what your role is here at ERC, please.
So I'm part of the science team. I'm the one of the persons who designed the Marsyard, and we look at how the rovers conclude the task related to exploration of the whole Marsyard and analyzing the geological features on the whole area.
Okay, so tell me a little bit about your background. How did you end up as a member of the science team at the European Rover Challenge?
Okay,
are you a rocket scientist?
No, I'm a software engineer, and I work in the space sector in GMV. I work with the payload data from the satellites. I also study automatics and robotics control. Geology is more like a hobby to me, to be honest. So I don't have any official background, I would say, related to geology.
Okay.
But I have enough knowledge to be a part of the science team, it turned out.
Well, I'd say you know about data analysis, you know about how the space industry, how space works, how rovers work.
Yes, I know about space sector, I think a lot as for a student. And I really like being a part of this space sector in Poland, because this is the part of the of the market that is evolving in our country. It's not big yet, so you have to look for the knowledge very often outside of the university, because you won't find enough information and experience in there. Of course, you can have the basic background and so on, but the real stuff, you will find it in the companies, in the student scientific associations, and so on.
Okay, so tell me a little bit about your study. You studied software engineering?
Yeah, automatics and robotics control, which was mostly related to software engineering, exactly. Maybe a little bit to the mechanical engineering as well.
Yeah. So how much of your curriculum in university was about space?
Not much, to be honest. I tried to be a part of the space myself. For example, I had a few optional courses on university related to the satellite engineering and so on. And I was trying to be involved in them. And my engineering thesis was also related to space. I hope that my master thesis will be related to space as well. And I was also the part of the team that was sending the student satellite a few years ago. And I think that's all if it comes to the university.
Okay, that's a great example, I guess, again, and we're seeing several examples of if you're dedicated to space, if you're interested in space, if you're a space geek, apparently, like you and me, whatever you study in university, you can find an angle related to space.
Exactly, yes. I have seen the people that are saying that you have to be a software engineer or the mechanical engineer to be the part of the space sector. I totally disagree. You can be nowadays a lawyer, you can be an artist. Each single job can be related to space nowadays.
I really like you saying that, an engineer saying that we need lawyers and artists and people from outside of science and engineering, even being an engineer yourself, but it's so true.
Yeah,
we need lots of engineers. Now let me look very quickly, as a last question, at career perspective.
Yeah.
How easy is it for a software engineer to find a job in space? In Poland, in your case?
In Poland. Well, I think in Poland, software engineer in space is the job that it's easiest to find in the space sector, to be honest. Also the mechanical engineer and electronic engineer.
Okay. Do you hear that?
I think those are the three most important segments in Polish space sector.
Exactly, and that is what I hear in other countries as well. So if you're studying software engineering, you don't have to work in fintech or in health tech or in edutech.
Yes,
you
exactly.
can work in space tech, and there is no industry cooler to work in than the space sector. So thank you very much for confirming that and being a live example of if you want to work in space, you can work in space. And that will only get better in the future now that the space sector is booming. So
yes, I totally agree that the sector will be evolving, becoming larger and larger, especially in Europe and Poland. So the new jobs will be also an option.
Excellent. Excellent. Well,
thank
you very much for sharing that with us and hopefully giving people ideas of their career in space.